Welcome to this video titled Ohmic versus Non-Ohmic. And at the end of the last video, we were talking about how the resistance of an object or a resistor is defined. And just as a quick review, it was defined as the resistivity, which is the material of the resistor, times a ratio of the length of that material to the cross-sectional area of that material. Now we remember that the resistance was measured in ohms, and so this term ohmic or non-ohmic is related, of course, to the resistance of the resistor. Now basically, the main difference between ohmic and non-ohmic resistors, or materials that follow what is known as Ohm's Law to materials that do not, is really all in the ratio of the potential difference to the voltage. Potential difference to the current. So if I were to graph the current versus the potential difference, and I saw a direct proportion, and remember that proportion was 1 over R. If I looked at these relationships, what I'm essentially saying is the more potential I establish across my circuit, the more current I establish at a direct proportional increase. So in other words, this resistance here is independent of the current or the voltage. So this would be considered an ohmic resistor. Ohmic resistors are independent, their resistance is independent of the voltage applied to them or the current flowing through them. They basically are defined on their own terms by this equation. Non-ohmic resistors might be something like an LED, a light-emitting diode, or other kinds of diodes where when I look at the relationship between I and V, I might get something that looks kind of like this, where it's not directly proportional. In other words, when there's very low voltage and therefore very low current, there's not very much resistance, but the resistance increases as I increase the potential difference, and this causes different effects. So in other words, for non-ohmic materials are where the resistance of the resistor, right, the resistance itself is affected by the voltage applied to it and the current running through it. And so in other words, this equation doesn't do it enough definition or doesn't explain it enough, and there's actually something else involved when we're looking at ohmic versus non-ohmic. So when you use Ohm's law, you have to be very careful because Ohm's law, which states that resistance is the direct proportion of the voltage to the current. This, in other words, is saying that resistance is independent of voltage or current, oftentimes looked at as delta V equals I times R. This only works for material that is considered ohmic, or where resistance is independent of the voltage or current. Ohm's law doesn't really work anymore specifically when you're looking at non-ohmic material. Now, does it say that current and voltage have a proportion where as I increase voltage, current increases? Yeah, they are still increasing. So it's showing some kind of proportion between voltage and current, but this is at a non-constant rate, meaning that the material or the resistance of the material is actually being affected by one of these things as well. And we'll look at that in a lot greater detail later on.